So question 17, the doubts which I received, question 17, 22, 23, 24, 25. So in question number 17, in which of the following is a vector fully described? So vector fully described here refers to, because a vector quantity is having a magnitude, unit, as well as the direction. So which one vector is fully described in question 17? So when you check a car travel north, so direction is given, but the magnitude is not given. Like a car travel north, direction is there, but what is the displacement or what is the speed not given. A crane moves a load 20 is a magnitude, meter is a unit, and east is the direction. So actually this is completely explained. But a train travel at a rate of 35 meter per second, speed is given, but it's not given which direction the train is moving. So it's not a vector quantity. A lift move upward kinetic energy 2.5 kilojoule. Here they mention upward, but what is energy? Energy is not the vector quantity. Energy is a scalar quantity. It is independent of the direction. That's why B is the correct answer. Is it clear why B is the right answer for this? Then question 22. In question number 22, the equation relating F, U, and V, rearrange this equation to show that the gradient is -1 and intercept, the y-intercept is equals to 1 over F. So we have to rearrange the equation. So one of the quantity should be on x-axis, the other quantity will be on the y-axis. So if we rearrange this equation, we have 1 over F is equals to 1 over U plus 1 over V. We want y because the equation of a straight line y is equals to mx plus c. So what we need on y-axis, on y-intercept should be either in a sum with the other quantity. So if I rearrange this equation, if I move 1 over u other side or 1 over v other side, so I can say 1 over f minus 1 over u is equals to 1 over v. Or if I rearrange this equation, I can say 1 over v, I just change left hand side with the right hand side, is equals to 1 over f minus 1 over u. But what I need on y-intercept, I need 1 over f on y-intercept. So that should be separated, like that should be after mx. So the order, when I change the order, so 1 over v is equals to minus 1 over u plus 1 over f. So when I compare now this, so the equation is now rearranged. So 1 over v is equals to minus 1 over u plus 1 over f. So when I compare now, y is equals to mx plus c. So if on y-axis I have 1 over v, so on y-axis if I have 1 over v, on x-axis I have 1 over u, what will be my gradient? The slope, because what we are left with m is equals to -1. And that also we have to show that the gradient is -1. And the y-intercept is equals to 1 over f. So you can see the y-intercept is equals to 1 over f. So we have to rearrange the equation so that it appear as same y is equals to mx plus c. Because 1 over f is on the y-axis, y-intercept, so we have to separate this first, and it should appear as the same like y is equals to mx plus c. Is it clear? Is it clear, this part? Then question 23. Explain why the graph of V against the F is a straight line and how the gradient can be used to find the Planck's constant. Here, this H is known as the Planck's constant. This is known as the photoelectric equation you will learn in unit 2. So first we have this EV E is a charge of electron which is 1.6 exponent minus 19 coulombs. So we want to plot a graph between V and F. So if you want to plot a graph between V and F, so E is extra here. So if E is multiplied, other side it will divide. So it will be V is equals to H over E into F minus phi divided by E. Because it is divided, so it will be under both numbers. Now when I compare with Y is equals to Mx plus C. So if on Y-axis I have V, on X-axis I have F, because I want to plot a graph between V and F. So what is my gradient? The gradient is Planck constant divided by charge of electrons. So both are constant. So whenever you divide two constant, you will get a constant answer. And whenever a gradient is constant, it will be a straight line. And but what is the y-intercept here? The y-intercept is minus phi by E. So what it shows? It will have intercept. Negative y-intercept means the graph will be somewhat like this. If y-intercept was 0, then the graph between V and F will start from origin. If y-intercept was positive, then the graph will start above the origin. But this will be the right graph in which the gradient, the y-intercept, is minus phi by E. So why it's a straight line? Because we have to show that it's a straight line. So why it's a straight line? Because the gradient is Planck constant divided by charge of electron, which is also constant. So when you divide the two constant with each other, you will get the constant answer. That's why gradient will be constant. And using this gradient, you can find the Planck's constant. Because how a gradient can be used to find the Planck's constant? So you have the formula gradient is equals to h divided by E. So I need a Planck constant. So E will be multiplied with a gradient. What I will get? I will get the Planck's constant. Is it clear? Question 23. Question 23. Then question 24. To determine the gravity, the acceleration due to gravity, the student uses the equation v square is equals to u square plus 2as. Show that y a graph v square on y-axis and s on x-axis should be a straight line through the origin. So why this graph should be a straight line, first thing, and then the second thing, it should start from origin. So reason for that, you have this equation v square is equals to u square plus 2as. Because whenever object is dropped, what is the initial velocity for object which is dropped? So u will be equal to 0. So in this equation, u will be equal to 0, the initial velocity. So I can say v square is equals to 2. And whenever the falling object is there, that's always fall up. Without air resistance, its acceleration is due to gravity and s. Now if I compare y is equals to mx plus c. So on y-axis, if I have v square on y-axis, on x-axis, because there is nothing added, so added 0 will be there, so y-intercept is 0. On x-axis, if I have distance, what will be my gradient? My gradient will be equal to 2g. So 2 is constant and gravity is constant. That's why gradient is constant, so it will be a straight line. And how we know it is passing through origin? As you can see, there is nothing added to this, or y-intercept is 0. So when a y-intercept is 0, it should be a straight line which is passing through the origin. Is it clear, this one? Now, in an experiment to measure the viscosity of a glycerol, viscosity is denoted by the symbol eta is there. The steel spheres are time falling through the column of a glycerol. The relation is used. Why the graph of V on y-axis and R square on x-axis should be a straight line with a gradient. So basically, whenever we want to show a straight line which is passing through origin, the y-intercept will be 0. So we have the equation. The equation is y is equals to mx plus c. So if on y-axis I have v, on x-axis I have r square. So what I'm left with, that will be the gradient. Other than r square, what I'm left, that's gradient. So what I'm left with, 2g, the difference in the density, divided by 9 eta. So 2 is constant, gravity is constant, density is constant at a specific temperature, 9 is constant, and viscosity is also constant. So all the constants are involved. So that's why if all the constants are involved, it means it will be a straight line. That is one thing. But whether this straight line will start from origin or above origin or below origin, so how you can identify? Because in this case, the y-intercept is 0. Means you can see here nothing is added, 0 is there. So y-intercept is 0, so it will be a straight line which is starting through or passing from origin. Is it clear?